This side of the cassette is related to your work in Unit 3, Section 1. You should have the source book available to refer to as you listen. Professor Geoffrey Lloyd is Professor of Ancient Philosophy and Science at the University of Cambridge. From his rooms at King's College, he recorded this talk on Greek notions and practice of proof.
Did the ancient Greeks invent the notion of proof? If so, can we say how and why? To see whether they invented the idea of proof, we must become clear just what it is we're talking about, and in particular draw two separate distinctions. I want to distinguish between the actual practice of proof and having proof as a concept. I will claim that the Babylonians, Egyptians, and others left evidence of having proved things, but it was only with the Greeks that we find an explicit and self-conscious attentiveness to the concept of proof. The second distinction we need to make is between informal and rigorous proof. In some spheres of Greek life, there was a lot of rhetoric about proving things, convincing other people that something or other is true. These techniques are best described as informal proof. This contrasts with rigorous proof, which is demonstration by deductive argument from clearly identified premises. Nevertheless, these informal methods of proof are important for showing how widely across Greek culture the notion of proving something went. Let's look at the first crucial distinction between proof as practice and proof as a concept. Let's go back even earlier. Both Egyptian and Babylonian arithmetic and geometry provide plenty of evidence of the practice of proof, in the sense of getting results by deductive argument. But the evidence for explicit notions of proof is limited. In some Egyptian arithmetical texts, for instance, we find proof in the loose sense of the confirmation or checking of a result. Problem 24 of the Rind Papyrus is an example. That's on page 14 of your source book, and you looked at this in detail in the section on Egyptian mathematics in Unit 1, Section 3. The scribe works through to the solution of a problem. Then he checks that his result is correct in the doing as it occurs. This is often rightly translated as the proof. Here, then, we have evidence of an appreciation of the need for checking and of a notion of proof in that informal sense, but still no explicit concept of proof in the rigorous sense of demonstration by deductive argument from clearly identified premises. Let's turn to the evidence on these matters from ancient Greece. It's wise, as always, to begin with a caution. Our information on certain points isn't as full as we should like. And as we shall see, there are some tricky problems in interpretation. But let's look first at the points that are clear. In the evidence that survives, the first explicit analysis of rigorous proof comes in the middle to late 4th century BC in Aristotle's Formal Logic. Aristotle also describes what counts as proof in the context of rhetoric, where proof is simply what will persuade an audience. There, arguments don't need to be flawless as long as people are convinced by them. In this, Aristotle was drawing on earlier discussions, for example, in Plato. Aristotle wasn't the first to study rhetoric, but he was the first to analyze deductive argument in a formal way. He says that demonstration is deductive, and more specifically, syllogistic. This means that you take two propositions and from them deduce a third. You start off from premises that must be true, immediate, and not derived from anything else, that can't be proved, but can explain conclusions. Demonstration gives us the knowledge to understand not just facts, but their explanation or causes. Aristotle is clear on some fundamental points. First, deductive argument is wider than demonstration. For deductive arguments may be valid or invalid, and valid deductions can be drawn from premises whether or not those premises are true or false. Here's an example of this. Take the argument, all animals that live in the sea are fish. Whales are animals that live in the sea. Therefore, whales are fish. The validity of the argument is impeccable. What that means is that if both premises were true, the conclusion would follow. But in my example, the first premise is false, and the conclusion also is false. And now for the second fundamental point about Aristotle's definition. Not all true propositions can be demonstrated. For example, the primary premises from which demonstrated conclusions follow must themselves be indemonstrable, to avoid an infinite regress. For what premises could they be demonstrated from? Take the so-called equality axiom. Take equals from equals, and equals remain. That can't be proved from premises that are prior to it. What was the background to Aristotle's work here? There were four possible influences. Firstly, arguments in law and politics. Secondly, early Greek natural philosophy and medicine. Thirdly, mathematics. And fourthly, deductive argument in philosophy. The arguments in law and politics and natural philosophy and medicine relate to informal proof, and mathematics and philosophy relate to strict proof. The Greeks were a litigious lot and very fond of going to law. They had a rich vocabulary for use in evaluating evidence, examining witnesses, arriving at an impartial judgment, and so on. But they also refer explicitly to proving their case, using especially a variety of nouns and verbs with a root meaning show. We can't date precisely when they were introduced, but we have plenty of evidence relating to their use from the middle of the 5th century BC onwards in the writings of such orators as Antiphon, Lysias, Andocides, and Isocrates. Proof can be attempted either about the facts of a case, what was done or who did it, or about their interpretation, the motives of the agents, and especially the guilt or innocence of the parties involved. What counts as a proof is what the speakers believe will establish their point beyond reasonable doubt, though they're aware that their own claims to have proved their case will often be rejected by the other side, to whose objections they will in turn object as being quite unreasonable. The same vocabulary of proof, evidence, consistency, examination appears also outside the legal political domain, particularly in certain contexts in early Greek speculative thought. Let me give you an example from the medical treatises which date from the late 5th or early 4th century BC and which are collected in the so-called Hippocratic corpus. These often claim to have shown the theories proposed on such matters as the origins of diseases. Some works go further and suggest they have shown the necessity of their conclusions. Here is an example from a popular lecture in the Hippocratic corpus called The Nature of Man.
I propose to show that the substances I believe compose the human body are always the same and unchanging, in youth as well as in age, in cold weather as well as in warm. I shall produce proofs and demonstrate the causes both of the growth and decline of each of the constituents of the body.
The physician is here wanting to demonstrate that the body is made up of 4 elements, 4 constituents: blood, phlegm, yellow bile, and black bile. Here's part of his argument. When you've heard it, switch off and consider whether the form of the argument is a familiar one to you. Then switch on again for my comment.
Some physicians assert that man is composed of blood, others of bile, and some of phlegm. These all make the same point, asserting that there is a basic unity of substance, although they each give it a different name. Now, I do not agree with these people. I hold that if man were basically of one substance, he would never feel pain, since, being one, there would be nothing to hurt. Moreover, if he should feel pain, the remedy likewise would have to be single. But in fact there are many things in the body which, when abnormally heated, cooled, dried or moistened by interaction, engender disease. As a result, disease has a plurality of forms and a plurality of cures.
The heart of the physician's argument here is that there's more than one essential constituent of the body. The argument is structurally an informal version of what you've met in mathematical proof under the name of reductio ad absurdum. He said, suppose human bodies were of only one substance, then certain conclusions would follow, which contradict aspects of our everyday experience, that bodies can feel pain, that there are different diseases with different cures. This contradiction of what we know shows that the initial assumption that bodies consist of one substance must be wrong. This physician produces some good arguments to demolish a rival view. But when it comes to clinching the case for his own theory, he's much weaker. The same must also be said of most other early Greek medical writers. Judged from the standpoint of formal demonstration, or even just of deductive argument, their performance often looks pretty feeble. Often the evidence they give isn't enough to substantiate their claims. And their inferences are sometimes shaky, even if you concede the premises. But perhaps that's not the right standpoint from which to judge these texts. We should compare them rather with the orators, who claim that the witnesses on their side are the reliable ones, and who end their speeches by the suggestion that they've cleared up every doubt on the issues when they know very well that they haven't. We've looked at some informal notions of proof in various contexts, but in addition, there's good evidence for the development of formal techniques of demonstration in other areas. Let's look at what notions of proof there were in Greek mathematics. Who were the earliest Greek figures connected with mathematical proof? It's true that some of our later sources, like Proclus in the 5th century AD, ascribe a number of theorems and their proofs to Thales, about 585 BC, and to Pythagoras himself, later in the 6th century BC. Yet we must be sceptical, both about their theorems, and even more so about their proofs. It's well known that the late Greek commentators tend to attribute sophisticated ideas to the heroic founders of Greek philosophy, and this is an example. At least if Aristotle is anything to go by, and he's much closer in time to those concerned, he always expresses himself in very guarded terms about Thales, who probably left no writings, and about Pythagoras. Aristotle ascribes no concrete mathematical doctrines to him. All he does is report the general views of some of the Pythagoreans who were at work in the mid or the late 5th century. Our first really solid information relates to the work of Hippocrates of Chios sometime around 430 BC, not to be confused with his namesake, the physician Hippocrates of Kos. The evidence about Hippocrates of Chios is of an altogether different quality. Not only do we have general reports of his work, for example, that he was the first to compose a book of elements, that is, a systematic presentation of a body of geometrical theorems. We also have a detailed account, in the commentator Simplicius, of Hippocrates' work on the quadrature of lunes. Though we have to make allowances for some rewording and interpretation in the process of transmission, we may accept that the substance of the 4 proofs of the quadratures of different lunes represents the work of Hippocrates himself. The proofs are impressive, not just in the extent of the mathematical knowledge shown, but also in the general rigor of the demonstrations. For instance, Hippocrates of Chios doesn't just construct lunes with an outer circumference greater or less than a semicircle, but in both cases provides proof of these inequalities. Now let's see if proof occurs earlier than this in philosophy. The first sustained deductive argument in philosophy, the first surviving one in European literature, is some decades earlier than Hippocrates. This is Parmenides' philosophical poem, usually thought to date to around 480 BC.
I will tell you the only ways of enquiry that are to be thought of. The one, that it is, and that it is impossible for it not to be, is the path of persuasion. The other, that it is not, and that it is needful that it not be, That, I declare to you, is a track from which nothing can be learned. For you could not know what is not. That cannot be done, nor indicate it.
It would be useful for you to switch off now and read again the extracts from that in the source book, item 2C1. Then, when you're ready, switch back on to my commentary. What Parmenides calls the way of truth takes as its starting point the proposition that it is. One way to understand this is to take it that he's claiming that for any inquiry to get anywhere, it must be an inquiry into something. However, Parmenides then proceeds to show a whole series of highly counterintuitive conclusions. For example, that coming to be and changing are impossible. Coming to be has to be ruled out because the only thing it could come to be from is what is not, and nothing can come to be from the totally non-existent. Apply this to the world in general, and we can see the force of the point that it's hard to understand what it would mean to say it came from nothing. Moreover, Parmenides drives the point home by asking why it should do so at any one time rather than at any other. Another good question for Big Bang or any theory of cosmological creation. But Parmenides isn't just interested in, as it were, unqualified coming to be, but in any kind. For he goes on to refute change too, precisely on the grounds that it involves a coming to be, to wit, of the new situation created by the change, and coming to be has just been ruled out. Plenty of aspects of the interpretation of Parmenides' philosophy are controversial, but it's not the content of his argument, but its form that concerns us here, and that's not in serious doubt. Evidently, he's attempting to arrive at a set of incontrovertible conclusions by deductive argument from premises that have to be accepted. So, from the 5th century BC, mathematics and philosophy provide excellent examples of rigorous demonstration. In neither field is there, at that stage, any formal analysis of the concept of proof. Indeed, compared with later, the vocabulary available for describing the elements and procedures of a proof is very limited. There have been disputes about whether it was the philosophers or the mathematicians who first invented such rigorous arguments, and who then influenced whom. So far as the most reliable evidence goes, if we stick to that, the philosophers have it. But we should be careful. For one thing, neither philosophy nor mathematics was a clearly defined profession, and many individuals combined an interest in both. Also, even in the 5th century, the two fields were developing quite distinct interests and techniques. However, I'm more concerned with what they both have in common, and the answer to that will provide a clue to the answer to the second part of my original question. Why did the Greeks develop a notion of proof? I said that the Greeks were always going to law, and they were also highly political. From the 7th century onwards, the Greek world began to include city-states. These were comparatively small, autonomous, political units like Athens or Corinth. In these city-states, people participated intensely in political debate. This was especially true in the democracies, but also in the oligarchies. The Greeks were keen to analyze forms of political constitution and legal codes. Indeed, it has been said that the Greeks invented politics as a field of study. Self-consciousness about skill in speaking, about techniques of argument and persuasion, may be seen as one aspect of the increased self-consciousness shown in political life generally. In part, the ambition to make arguments rigorous and to analyze what makes them so, in philosophy and mathematics, belongs to the development of mathematics and philosophy themselves. But perhaps in part, the Greeks desired incontrovertibility because they were dissatisfied, not just with informal techniques of showing points, but also with rhetoric. It was all too obvious that what persuaded people in the law courts and the political assemblies might or might not be true. In some contexts, as we saw in medicine, people used informal notions of proof mainly to persuade. But for some purposes, and in other contexts, that clearly wouldn't do, and people wanted something that was incontrovertibly true rather than just persuasive. Once models of rigorous demonstration existed, and their formal analysis had been given by Aristotle, the influence of this ideal, not just in areas of philosophy and mathematics, but also in the exact and even the natural sciences, was immense. But that's another story.